público, bienvenidos una vez más a una emisión más de La Esfera de la Vida. Hoy les hablaremos sobre la biodiversidad de México, pero para saber un poco más de esto tendremos que hablar sobre varios temas. El primero es el concepto de especie. Bueno, pues especie viene del latín tipo o apariencia. A lo largo de la historia ha habido varias controversias y debates sobre su significado. Y bueno, Linneo lo introdujo y creó varias categorías que son taxones y nombre científico. Especies son organismos que tienen un genotipo y fenotipo similares. Esto es el acervo genético. Y bueno, el acervo genético es la reproducción sexual. Cuando individuos de la misma especie se aparean, tienen que dejar descendencia fértiles. En algunos casos, cuando el burro se aparea con la yegua, tiene como resultado la mula. La mula no es fértil y pues no puede dejar como que sus hijitos. Entonces, la mula está aislada reproductivamente y esto trae como consecuencia que se interrumpe el flujo génico. Asimismo, individuos de la misma especie coexisten en un tiempo y espacio determinado. El siguiente tema a tratar es procesos de especiación. ¿Qué es especiación? Es un mecanismo en el cual surgen nuevas especies. Y ahora, para profundizar más en el tema de procesos de especiación, en nuestra siguiente sección de Biología Internacional, nuestros amigos en Estados Unidos nos han mandado un video con los diferentes tipos de especiación.
One way for a new species to evolve starts when a few individuals colonize a new area that is outside their native range. Take, for example, a volcanic island that rises out of the sea just off the coast of the mainland. Over millions of years, as the island grows larger and less volcanically active, plants begin to grow, but there are no birds here yet. Then one day, birds from a common species on the mainland are blown over by a storm and start a new population. If these birds move between the island and the mainland only rarely, the conditions for reproductive isolation are set, and the brand new island population is on its way to becoming a new species. Over thousands of generations, the two populations will be shaped by natural and sexual selection into separate forms, each with a unique genetic fingerprint. But at what point are we confident that this island population has really changed enough to become a new species? Well, let's put our definition to the test. If we introduce a female from the mainland species to a potential mate from the island after 200 generations in isolation, about 400 years in bird terms, will they mate? It appears that these two still recognize each other as members of the same species. How about after another 1,000 generations of isolation? Now, the female finds this island male's song a bit strange, but she still chooses to mate with him. What if we fast forward again to 10,000 generations of isolation? This time, the female doesn't even recognize the male song and is completely uninterested. If this female's mating preferences are widespread in the population, we now have two bona fide species, mainland and island. Here, because our birds avoid flights across the open ocean, island birds do not regularly encounter mainland birds. Because genes from the two populations no longer intermix, genetic differences accumulate, and the two populations become different species. So in practice, scientists classify species separated in space by their genetic differences, not by observing blind dates. But there is another kind of speciation that can occur when a habitat becomes divided and a once widespread bird population becomes fragmented. Imagine that our new island grows larger over time and the volcano develops a central mountain ridge while a valley forms along the eastern coast. Over time, the eastern birds, who have plentiful fruit resources and only need a single parent to successfully raise young, evolve specialized mating systems. Males compete for multiple mates and, to get noticed, evolve fancy plumage and display behaviors. On one side of the valley, the males evolve elaborate head plumes, and on the other, it's the tails that get fancy. At the same time, Western birds are consistently dealing with harsher food conditions and do not evolve a specialized mating system or fancy feathers. Just as before, early in the speciation process, when individuals from isolated populations meet, our eastern and western birds readily mate. But as generations pass and the eastern males become fancier, the western females begin to find the eastern males' habits foreign and surprising. But these traits are clearly not deal breakers. Even after 10,000 generations of geographic isolation, some of the western females continue to find the males' displays attractive. At this stage, the eggs she lays aren't viable because the separated populations have evolved too many genetic differences to be compatible. To review, in this kind of speciation, geographic barriers have split the habitat into 3 fragments, and on each, a unique species evolved. What if the southwestern slope erodes into a low peninsula, allowing southeastern birds to mix with the western birds? By this time, their mating systems are completely different, and the two species can't create fertile offspring. Now, related species can coexist, but because they no longer successfully interbreed, there's no going back. So how did the 39 bird of paradise species evolve from one crow-like ancestor? New Guinea and the surrounding islands where birds of paradise evolved have changed dramatically throughout geologic time, repeatedly isolating populations. Over thousands of generations in isolation, natural and sexual selection have morphed the fragmented populations into a wonderful array of colorful species. The process of speciation is ongoing, and split after split, new and unique organisms evolve. Incredibly, all those 10,000 bird species we see today evolved from one single bird ancestor. And it's thanks to the evolutionary processes driving speciation that our planet is home to such impressive biodiversity.
Y ahora, continuando, nuestra siguiente sección es La Voz del Estudiante, en donde nuestros estudiantes envían sus videos sobre temas que dejamos en programas anteriores. El tema fue patrones evolutivos. Entre muchos, el mejor video fue el del estudiante Stephanie Beltrán Esparza. Veamos su video. Y bueno, ese fue el video del estudiante Stephanie Beltrán. Recuerden mandarnos sus videos a la dirección que está apareciendo abajito. Ahí recibiremos todos sus videos. El siguiente tema es fotosíntesis. tenemos una transmisión con el biólogo Sergio Currilla, que nos hablará sobre la biodiversidad en México. Vamos con él. Gracias al biólogo Sergio por su participación.
Hello, Twitter bird. En nuestro Twitter nos mandaron: los elefantes pertenecen a su hábitat, no a los circos. Libertad para los animales, no más animales encerrados.
Bueno, eso fue todo por hoy. No olviden sintonizarnos en la próxima emisión de tu programa La Esfera de la Vida.
She was just a girl, she expected the world, but it flew away from her reach, so she ran away in her sleep, and dreamed of paradise, every time she closed her eyes. She was just a girl.